Many people notice the same quiet changes as they get older. Their feet feel colder than they used to. Walking long distances becomes harder. A dull cramping sensation appears in the calves after only a few minutes of movement. At first, it seems minor, just another inconvenience of aging. But over time, the pattern becomes clearer. The legs tire faster. The skin on the lower legs may look slightly darker or thinner. And sometimes the body sends a subtle warning, a pulsing ache that disappears the moment you stop walking. Most people blame the heart. They assume the heart is getting weaker, that circulation is simply declining with age. But the heart is often not the real problem. In many cases, the issue begins somewhere much smaller, inside the microscopic lining of the blood vessels themselves. Because blood vessels are not rigid pipes. They are living tissue, and their ability to expand and deliver blood depends on a tiny signaling molecule that most people have never heard of. A molecule called nitric oxide. When nitric oxide levels drop, blood vessels lose their flexibility. They narrow slightly. Blood flow slows. And the first place you often feel it is in the farthest parts of the body. The legs, the feet, the smallest capillaries where oxygen must travel the longest distance. Circulation problems don't always begin with blocked arteries. Sometimes they begin with the gradual disappearance of the molecule that tells your blood vessels how to open. Inside every healthy artery, there is a thin layer of cells called the endothelium. This layer does something remarkable. It constantly senses the pressure, speed, and chemical composition of the blood moving past it. And when the body needs more circulation, these endothelial cells release nitric oxide. Nitric oxide works like a molecular signal. Within seconds, it tells the smooth muscles surrounding the artery to relax. The vessel widens. Blood flow increases. Oxygen delivery improves. This process is happening thousands of times every minute throughout the body. It is one of the most important mechanisms keeping circulation efficient. But as people age, nitric oxide production often declines. Several things contribute to this. Oxidative stress damages endothelial cells. Poor diet limits the nutrients required to generate nitric oxide. And sedentary lifestyles reduce the mechanical signals that normally stimulate its release. When nitric oxide production drops, arteries become slightly stiffer. The change may be small at first, but even a modest reduction in vessel flexibility can significantly reduce blood flow to distant tissues like the calves and feet. The body tries to compensate. The heart may pump harder. Small collateral vessels may develop over time. But the fundamental signal, the one telling arteries to relax, becomes weaker. And that is where nutrition begins to play an unexpected role. Because the body has another way to produce nitric oxide, a pathway that starts not in the blood vessels, but in the foods we eat. Plants absorb nitrogen compounds from the soil as they grow. Many vegetables store these compounds in the form of dietary nitrates. When humans consume nitrate-rich vegetables, something fascinating happens. The process begins in the mouth. Bacteria living on the surface of the tongue convert dietary nitrates into nitrites. These nitrites are then swallowed and enter the acidic environment of the stomach. There, another transformation occurs. Nitrites are converted into nitric oxide. This alternative pathway allows the body to generate nitric oxide even when the endothelial system is less efficient. In other words, certain foods can provide the raw materials needed to support blood vessel function. Scientists have been studying this pathway for decades. Research on dietary nitrates has shown measurable effects on blood pressure, arterial stiffness, and blood vessel dilation. Athletes were among the first groups to notice the benefits. Some studies found that nitrate-rich foods improved oxygen delivery to muscles and enhanced endurance during physical activity. But the same mechanism can also benefit older adults whose circulation has gradually slowed. The body simply needs the right compounds to restart the chemical signals that relax blood vessels. And some vegetables happen to be particularly rich in these compounds. Among the most studied sources of dietary nitrates is the beetroot. Beets contain one of the highest concentrations of naturally occurring nitrates found in common foods. When consumed as beetroot juice, these nitrates are absorbed rapidly. Within a few hours, the body begins converting them into nitric oxide through the nitrite pathway. Several clinical studies have examined this effect using measurements such as flow-mediated dilation, a method used to assess how well arteries expand. In some experiments, beetroot consumption improved vascular dilation and reduced arterial stiffness. Other research has observed improvements in walking endurance and oxygen efficiency during physical activity. Another vegetable often highlighted in nitrate research is arugula, a leafy green with a particularly high nitrate concentration. When eaten fresh or blended into smoothies, arugula can provide a concentrated source of dietary nitrates. Celery is another plant that contributes meaningful amounts. While its flavor can be strong, celery juice has become popular partly because it delivers nitrates in a simple liquid form that the body can absorb quickly. And not all circulation-supporting drinks rely on nitrates. Hibiscus tea, for example, works through a different mechanism. Hibiscus contains polyphenol that appear to support vascular health and may contribute to reductions in blood pressure in some studies. Each of these foods works slightly differently, but they share a common principle. They provide compounds that help the body maintain the delicate chemical signals required for healthy blood flow. The nitrate pathway, however, depends on a surprisingly fragile biological system. Remember the first step in the process: the bacteria on the tongue that convert nitrates into nitrites. Without them, the entire chain reaction becomes less efficient. And one common habit can interfere with this step. Strong antiseptic mouthwashes can temporarily eliminate many of the bacteria responsible for nitrate conversion. Some studies have suggested that excessive mouthwash use may reduce nitric oxide production from dietary nitrates. Another factor is food processing. Many commercial vegetable drinks contain added sugars or preservatives that dilute the concentration of beneficial compounds. Fresh vegetables generally provide a more reliable source of dietary nitrates. Even timing can matter. Consuming nitrate-rich foods on a relatively empty stomach may allow faster absorption before they mix with heavier meals. These details may seem small, but circulation itself depends on thousands of tiny chemical interactions happening inside the body every second. And when those signals weaken, the effects slowly become visible in the places where blood has the farthest distance to travel. Circulation is often described as a mechanical system. The heart pumps. The arteries carry blood, but the reality is more complex. Blood flow is also controlled by a constant chemical conversation happening inside the vessel walls. Molecules like nitric oxide tell arteries when to relax and when to tighten. When those signals weaken, circulation gradually becomes less efficient. The body is not suddenly failing. It is simply losing access to the compounds that once helped maintain that delicate balance. And sometimes restoring circulation begins not with stronger muscles or a faster heartbeat, but with rebuilding the chemistry that keeps blood vessels responsive. Because the health of your circulation is not determined only by how hard your heart works. It is determined by the tiny molecular messages that tell your blood where it needs to go. And those messages begin long before the blood ever leaves the heart.